Hi, this video will show you how to use resistors both in series and in parallel. In this circuit I've got a 10 volt DC supply over here as well as a 400 ohm resistor with an ammeter to measure current and an LED. If you'd like to know more about what resistor you should use to light an LED, then there is a video in the description below. But for this LED I want 20 milliamps of current to pass through it whilst using a 10 volt supply. Using Ohm's law, as mentioned in the video below, we can calculate that we need a resistance of 400 ohms to achieve this. If I now play the simulation, you can see the LED lights over here and there is 20 milliamps of current flowing through. Perfect. Now let's say that I don't have the 400 ohm resistor to hand. There are other ways to make that much resistance. One way to do it is by adding two smaller resistors together, like this, in series in a circuit. Here I have two 200 ohm resistors added together to make 400 ohms. Whilst the simulator is on, you'll see the current over here is drawing 20 milliamps across the LED, proving that the resistor combination here is exactly equal as the previous one. Let's take a look at the equation for adding resistors in series. R total, or the total resistance, is equal to the addition of both of the series resistors. You could do this with any number of resistors, just adding them all together in a line. Going back to our previous circuit, let's say I'm stuck with a 150 ohm resistor over here, and I need to work out what resistor to add to get to 400. Well, 400 minus 150 equals 250. And if I now simulate this circuit, you can see I get 20 milliamps of current flowing and the LED lights perfectly. Excellent. As a general rule, if you want to add resistance to a circuit, you should add an extra resistor in series. Now let's look at a more challenging way to use resistors, in parallel. In this circuit, I have the same layout as before, only instead of one 400 ohm resistor, I have two 800 ohm resistors in parallel. If I now play the simulation, you will see that I'm getting 20 milliamps flowing through the LED, meaning that the circuit is equivalent to our previous designs. Let's look deeper into what's going on here. The total resistance in a parallel arrangement of resistors over here is equal to the product of all the resistors divided by the sum of all the resistors. If that is confusing, it can be written in these ways as well. R total equals the product by the sum, as mentioned. 1 over R total equals 1 over R1 plus 1 over R2. Or R total equals 1 divided by 1 over R1 plus 1 over R2. All of these equations are equal. This may seem confusing at first, so looking back at our previous circuit, let's do the calculations. So 800 multiplied by 800, that's the product, divided by 800 plus 800, that's the sum, equals 400 ohms. Perfect. Now, as a general rule, resistance in parallel can only be as big as the smaller of the two resistors. So even if I had an 800 ohm resistor in series with, say, a 1 mega ohm resistor, as I'm showing here, the total resistance will still only ever be as high as the lowest resistor. So divided by 800 plus 1 million equals just under 800 ohms. Let's do an example. Let's say I'm stuck with a 500 ohm resistor and I need to know what resistor to add to it to get to 400 ohms. So here I have my R total being 400, so I want to get to 400 ohms. My R1 is the 500 ohms that I'm stuck with, and R2 is left empty. So multiplying out the bottom here, I have 400 times 500, which is 200,000, plus 400 R2, these two multiplied, equals 500 R2 over here. Then subtracting 400 R2, I get 200,000 equals 100 R2. Dividing by 100 gives us R2 equals 2000 ohm. Now let's try this number out. Here I have set up the 500 ohm resistor in parallel with the 2000 ohm resistor, or 2K resistor. If I now play the simulation like so, you can see we get 20 milliamps of current flowing and the LED lights. Perfect. This proves that this circuit is equivalent to our previous circuits as well. To summarise, if you want to add more resistance to a circuit, then you need to add resistors in series. If you want to lower the resistance in a circuit, then you need to add resistors in parallel. Thanks for watching. I upload a new video every Sunday. Be sure to like the video if you liked it and subscribe if you loved it. Have a good day. See ya.